All right. Hey guys, thanks so much for tuning in. It's really exciting to do this for all of you. Um, my name is Arthur. For those of you who haven't met me before, I'm a part of O&P Digital Designer. O&P Digital Designer is a masterclass series, an accredited training program on how to design in the O&P field using agnostic CAD. Agnostic CAD is a great solution, and I'm going to spend a few minutes talking to you guys about why and how this positions itself in the market the way it does. And then we're going to dive right in. And for the next hour, we'll be able, and I'm going to design from an absolute beginning, from the beginning of a scan to a completed CAD product for 3D printing. And you guys can ask me questions as we go. And I'm going to give you a special promotion today as well, as a thank you for showing up and being a part of this first webinar with me. So let's take the deep dive and let's just start. So O&P Digital Designer is the name of the company and the website that you guys can go check out. So who I am, here, I'm going to get rid of my face here for a second. So I'm an industrial designer by trade. So industrial design is the study of how things are made across many industries. I've worked as a digital design specialist in 3D design software for 9 years. I've worked in many industries, including like CNC, woodworking, props and films, PCB enclosures, medical design, O&P design, imaging, product prototyping, and a few more in there to boot. What's great about this role is that I get a chance to really see how things are made and, tour factories and look at how other people are designing, what softwares they use, how they're doing things. And as a result of working in all of them, I've had to really refine my technique over the years. And I've found a method that really is a strong candidate for the O&P field, which is why I'm deciding to bring it to the field. This academy is being used in several different clinics over several different companies. It's been trialed and printed against modern day devices as well and tested. It's being trained and implemented across the world, including clinics in Singapore, Nigeria, North America, and more expanding even into Europe. So it's an exciting time to be a part of this. It's using a new form of education, the education platform, and allows you to take control of your own education in this field. So why digital design? Digital design in O&P has many obstacles right now into getting into 3D printing. Namely, it's a big problem when it comes to inputs, processing, and outputs. So those are the three main parts of using digital design in O&P. So inputs, you have 3D scanning costs and quality concerns that are a big issue for many people wanting to get into O&P 3D printing today. In your processing, you have high costs of design and software subscriptions with long learning curves, which prevent many people from taking up the challenge. And then your outputs, buying and managing and running a production 3D printer is no joke. It's a huge expense, and it can be another really tall obstacle for many people today. So you can solve all of these problems with digital literacy. And digital literacy is the single most important thing any practitioner can do right now. And this gets them 80% of the way there into 3D printing and removes 90% of these barriers. And I'm going to break this down and show you guys firsthand. So the benefits of using design agnostic digital software, first off, it allows you to use standard product tools. And these are tools that are found in every industry. And what this allows you to do as an O&P practitioner is to, engage with the rest of the industry around you, because there's a lot of other mature agnostic manufacturing facilities online today that own and run expensive 3D printers. And they want to print for you. They want to print for anyone who can provide the parts and the necessary know-how to bring the business, because that's an existing market today that you can leverage. So if we're going to solve these three main issues with 3D printing, with digital literacy, what are the costs? First of all, what are the barriers in costs that we can remove? So the rest of the industry right now pays about 10 times less in design software costs than what O&P software is costing today. So for example, this software solution that we're going to be using today is equates to less than $1,000 a year in design software costs. And this is compared to, again, doing any other method. You can pay anywhere upwards of $20,000 to $30,000 a year in potential software costs. And this is just in design. So the processing and the design software alone, if you can use digital literacy and agnostic CAD, you can remove, again, this first barrier, which is one of the biggest ones, is instead of paying $1,000 a month in software costs using software as a service, you can spend $1,000 a year and have more choices in your design and have more control over your design process. So many people might be asking, because there are engineering softwares out there that everyone's heard of, Geomagics, SolidWorks, Inventor. What about Geomagics? Geomagics is a well-purported software in the field right now. I'm going to show you today that you can keep up with the results of Geomagics using these affordable softwares. But the biggest downside is that you're going to be spending a few more minutes per cycle between patients. But hey, you're going from $16,000 a seat with $2,500 a year in maintenance costs to own Geomagics, and then another $3,000 in peripherals and an expensive computer. You're saving about 16 times more by using this method, which again is agnostic, affordable CAD software. So this solves our processing. How do we solve our outputs? What is the obstacle there? It's 3D printing and owning a 3D printing machine and running it and the costs associated. So by choosing to use agnostic CAD, you're removing a huge financial barrier in software costs. And it also gives you this one thing that takes away this barrier as well in solving outputs, and that is running and owning a production printer. So if you are able to interface with the rest of the mature industry around you, people who have 3D printers online and engineering firms and production centers that are working in many different industries, if you can interact with them on their terms using their design guidelines and their software, you can forgo owning a printer altogether. You can have them print for you, and they're ready to go in this sense. So the barrier of owning a 3D printer or even having software that will print for you for 10 times the cost doesn't need to be there, as long as you decide to take up digital literacy in agnostic CAD. The final barrier in inputs, 3D scanning inputs, these methods I'm going to teach you today are not affected by poor or good scan quality. So you're going to be using as much time reverse engineering or working with scans of a poor quality scan versus a very high quality scan from a high quality device. So you can scan for free and learn how to design so that someday you can get someone else to print for you. So this is the game that we're playing here in terms of bringing digital design and affordable 3D printing to small to medium-sized mom and pop shops. So your input, processing, and output obstacles have been removed by doing this, right? I hope you guys can see that. So by using agnostic CAD, you can really get into the game that much more quickly and that much more affordably. So today and today only, there's going to be a promo code at the end of the course that I'm going to enable. And this is going to be the code that you're going to receive off $100 of any course of your choice from this program that I'm purporting. There's 3 main modules right now, and a further 2 are going to be released within the next 3 months. So OPTD Webinar 100 gets you $100 off any course of your choosing. And this will be, again, up for today and today only. So let me then, with that being said, let's jump in and dive in and do this right from the beginning. So I'm going to share my screen, and bear with me because this is a new program and I have just started learning how to use it. So share screen, going to start off from the very beginning in ZBrush, one of the first softwares we're going to be using. So now, can I look at where you guys are and just make sure I'm keeping track of the comments? So we're going to design together and start from scratch. If you guys want to leave any comments or ask any questions along the way, feel free. This is the part where we're just going to have some fun and we're going to do some design. So can I put myself down here? There we go. That makes more sense. And let's get started. So this is ZBrush, and if you buy the course from OPD Digital Designer, you actually get a custom menu that's very specific to orthotic and prosthetic workflows. So every button from every menu that you could possibly look for in this program has been put in order for you and into groups so that you have everything at your disposal and it lines it up for you and just makes it that much more easier to use this program, because this program can be very challenging. So we're going to start off by importing a scan mesh, and let's bring that in and see what that looks like. So I'm going to drag an instance of this on screen. I'm going to hit edit. I'm going to change my material. So you can see this is a scan of a plaster cast. And this doesn't have to be a plaster cast. You can use a scan of any kind. So you can scan the actual device or the actual patient, the plaster cast, whatever you'd like. I'm going to use this to start. So first things first, when we're cleaning up and preparing scans, we have to make sure they're properly aligned to the world space. So if I turn on my world space, there's my origin in the center. That's really important to be able to look at this from the top view, from the side view, from the left view, and not have it hanging around in space like this. So I'm just going to quickly use ZBrush here to ascribe some axes and snap it with holding down Shift. We're going to snap it to the axis so that when I hold down Shift, I can look at the front view and the side view. We're just going to spend a few seconds here getting that first step. So I'm going to try and line up the foot as best I can, taking it up straight up and down, and then moving it towards the origin space. That's step one. Now we're going to need to do step two, which is we're going to need to correct the anatomy. We're supposed to, reposition this foot so that it's neutral. The foot's inclined, going inward, medial, and the actual leg itself is not fully upright. So we're going to spend a few seconds here changing all of that. Forgive me, practitioners, I'm not a practitioner, so my terminology is rather poor. I speak in terms of product devices and digital workflows, so please make your comparisons in your head as we go. So first things first, I'm going to use some of these cool masking tools inside of ZBrush to be able to take, make a gradient selection, so that when I mask away something like this and create a mask, I can now ascribe where the rotation point happens and look at this from the side, and now hit rotate, and I can rotate this upright, which is our first step. Now it might not be perfect. We can use brushes to just sort of bump that in, because that doesn't quite look right. So, at your discretion. So that was step one. Step two is let's change the foot so that the foot is not inclined to the inside. So what I'm going to do is the exact same thing. We're going to create an alpha transparency that goes down the front side of the foot. So something like this. And we're going to turn off that alpha. We're going to mask away the rest, blend that together, change my mask so that only the front of the foot is selected. Now, what we can do is we can move our axis point to an anatomically relevant place, so that when we go and rotate this now, we're going to get that rotation in a realistic way. So that was maybe a bit more, something like this. So when you learn these tools, it's great to use them with medical expertise, because you know how anatomy can be modified, and you can use your best judgment to use these tools and leverage them the best way possible. So I'm basing this off of my experience as a digital designer working in this space. So the next step I'm going to do here is I'm going to try and flatten the sole of the foot for the AFO, because we still have an unweighted scan at this point, or a cast. So I can actually use these tools and flatten the sole to a large degree as well, and bring that in line with what a device would need for the foot plate. That's nice. Finally, when you do create a weight bearing scan, often the foot is sort of, you get an expansion on the lateral side. So I'm going to use my brushes again to sort of highlight this area that would expand. And this is to my eye. Feel free to use these tools as you see fit as you work. But I'm going to expand this out just a little bit to account for sort of a medial expansion. Maybe make sure that's not going down below the plane bottom as well. So there you have it. That wasn't too hard. With a few clicks, we were able to morph this into place using standard tools inside of ZBrush. Now that this is sort of more or less aligned, the next step is, let's clean up this seam on the front and clean up the top here as well, which has some junk on it. So I'm going to be able to actually just straight up cut that top right off. And now I can take that, if I turn on my fill, turn off my mesh, I can see I have a group up here that I can select. And I can feather that result, and we can move that just up to account for the lost height that I took from the scan. So that's really good. We're now ready to maybe smooth this, but now that we can do that, we can actually look at this mesh. So this mesh was done probably with a structure scanner by the looks of it. You can just sort of tell the mesh quality is pretty decent. It hasn't been sort of decimated or edited that way. So we have to, in our next step, we're going to dynamesh this, which is essentially a remesh at 428,000 points. That's probably too much. So I'm going to put that again at a lower resolution. Let's see, 245,000. That's also too much. For whatever reason, my undo button is not working right now. So I actually have to pull my undo slider back. Okay, so that looks about right. Turn off the lines. Let's just quickly use our smooth tool and let's smooth a lot of this out of the picture. So I can smooth, I can remesh and smooth again. Oh. Get rid of some of these blemishes in the front surface. Not that we need that too much in this. Yeah, so let me know how you guys are doing on this. Feel free to ask questions. I know we can't have a whole bunch of people talking at once, but the comment section's there for you. So I've now modified and we have it remeshed. It's at a decent resolution. We can now start to draw our trim lines as the next step. So I'm going to duplicate this scan now. So we have a second, and I'm going to work on a copy. And in this copy, I'm going to turn on a modifier to make my lines a little nicer. And I'm going to create a trim line. And, we're doing a traditional AFO, especially the one based on the image. So we have a liner to make, and we have the actual device going up to the shin. So we're going to start off with making the liner. So if I use my space mouse, I think that's going to make it a little easier. We can start to draw this out using a masking tool. So I'm going to drag and draw what, my best interpretation of an appropriate trim line. But you can see how this tool is really set up to be able to do a lot of what we do in OMP. It's just they don't have the same names. I can project also some lines through the scan as I work. So for example, I usually do this when I'm drawing a trim line because this allows me to match the height and the distance forward on this side with the other side as I travel across. So looking at it from the back now, we're going to continue this trim line over. And don't be afraid if it's wobbly or a little rough. I'm going to show you how robust this method can be, because you can sort of just rough it in and we can really refine it after the fact. So it's very versatile and very forgiving. So I'm going to go over the ankle joint. I'm going to go down below the 5th metatarsal head, and then I'm going to go and complete the front edge of the foot plate. And this front edge is really wobbly. Don't worry. Again, we are going to be able to modify all of this after the fact. This is just sort of roughing in the shapes for the scan. So let's call, whoops. Maybe I probably want this to be a little lower. So let's do something like that. I'm going to erase that. And maybe do something the same on this side before we come in. Go. So with something like this, we are now ready to create that trim line. So let's go groupings, and we're going to group by masked. If I clear this, nothing happens. If I turn on my groups, give me my groups, there we go. We have a drawn trim line as a group. We're now going to create groups for all of these pieces now as well, so that we can isolate this first piece. So at this point, I'm going to duplicate again. So we're working on a new copy, and I'm going to remove everything else that I don't want. So this one, we also need to auto group into separates. So I can remove this, and this, and this. So all we have left is that the device that we drew out earlier. See, they're not perfectly symmetrical. I mean, that's okay. We can also fix that a little later, not to worry. So what we have here is, on a separate part, we have our isolated surface. Above that, we have our scan that's been cleaned. And above that is the original. So we're about ready now to take it to the next step, which is we got to convert this messy mesh that we've remeshed into a quad mesh for CAD. Quad meshes are the secret sauce that combine mesh editing and mesh modeling with CAD workspaces. If you can find a way to do quad meshing, you're going to be in the game very quickly. So I am going to use the most powerful quad meshing tool in all of mesh editing tools, in my opinion. Believe me, I went looking for it. I audited Blender. I audited even the tools found within the mesh space of Fusion. Nothing compares to what this can do. So let me show you what I mean. So right now we're at an active target count of 93,000 points available here. I'm going to delete what's not visible. I'm going to remesh this while keeping those groups, because there's a rim group on this. And we're going to remesh this at a count of 5. Now let's see what happens. Takes a little bit, especially when you're streaming, but there we go. Let's see if I can turn that on a bit more clearly. So right there we have a quad mesh. Now we're at 5,000 points. That's about 5 times too much, in my opinion. So we're going to half this and remesh it again. So we're remeshing a quad mesh to make a quad mesh. And there we go. We're getting a bit better, 2,000 points. We can polish by groups to sort of round out our edges. And right there already we can see a massive improvement in sort of our edge quality and how things are flowing. Some things right out of the gate that we can improve would be the foot plate itself and making that flat and making that longer than the toes. So we're going to be looking at doing that right away. Something I do want to try and do, though, is just potentially make this rim symmetrical with the other side. So if I try and use a brush here and just sort of pull this up to more closely match the other side, that just makes probably for a neater design, more or less. But I've now moved it off the scan. You can see that, right? It's like inside the scan now. So hopefully I can just hit project all. No, it's a bit too far out. Project all will take anything and bring it back to any mesh that's invisible, which is why having a copy of the original scan is so valuable. So now that we have that in place, I've projected it back to the scan so I know it's accurate. Let's now remesh this at half strength again. So look what we're getting at. We're getting at 1,000 points. We're losing a bit of our trim line, just a bit. I mean, not bad. It's not terrible. We're going to have to re-pull up that corner a bit. So let's just, that might be something we have to account for. Bring that up so it's next to where our original is. If I turn on the original, we can kind of see where that's coming through. We might want a corner here. Go to the other side, bring up that corner, and we can project again just to bring it all back. This is very accurate, nice and smooth quad meshing. Let's now focus on the foot plate and clean up that foot plate. So I'm going to mask away the foot plate, blend it out a bit, hit my W move tool, place it on the floor plane, and then we can just two-dimensionally flatten that flat. And we can even use this tool to lengthen it and expand it just a bit. So like right there, it's like really easy to make that change now that we have a low poly, low dense mesh. So that would be the completed, ready to go, ready for CAD surface for our design for the AFO section. So now that we have that part, we're going to go back to our original scan. Let's duplicate this, or even just, let's just regroup this to the same group. And let's do this again. This time, we're going to be doing it for the liner on the inside. I forget what these are called. So someone pasted in the comments. If you remember what the liner on the inside of an AFO is called, I would love to be more accurate next time around. So I'm going to sketch out this trim line. So I'm following that and then coming up over the fifth metatarsal to near the midpoint. We're going to come up here and come down before going over the ankle bone, coming to the Achilles and coming back up. Man, my anatomy is so bad, guys. I wish I could give you better anatomy callouts as I work. A lot of my experience has been strictly through the design process and teaching people how, practitioners how to use the tools, which is fundamentally still what I'm doing. None of this I'm medically condoning, but the tools are is what I'm after, and teaching people how to use the tools. So, all right, so there is a trim line. I'm going to just spend a few seconds and maybe clean this up, get a nicer line going on the top. Not too worried about the inside because all of that's going to be grouped together. All right, so now that we have that, am I happy with this? I don't know if I'm happy with this. Just give me a second. Okay, there we go. Something like that. So again, nice and rough. It doesn't have to be perfect. It's very adaptable. So let's do the exact same process that we just completed for the AFO for the liner. So we are going to create a group from the masked area, clear that mask, select the other group, auto group those pieces so that we can select everything else but that, and delete hidden. So we now have a copy of this mesh as well. We've got a trim group as well as just a regular group throughout. Let's go ahead and quad mesh this back to something that's much more usable. So we're going to keep groups. We're going to use our quad meshing module inside of this. And we're going to spend a few seconds here waiting for this to compute. Not bad, not bad, not bad. We're going to polish just to get some of those trim lines to look a little nicer. We're going to half our Z measure target again and do that again. 2,000 points, not bad. I still would like it to be a little nicer. Let's try one more time at half. That actually might be a little too low. Just we're really starting to lose our trim line here, but I'll do my best. So we can go in and just clean this up a bit. Make sure that anything that got bumped around gets put back. Like this, maybe bring that corner out a bit more. So we have that. Right, so now that we have that, we can project again to bring that back in line with the scan below. It's not bad. So we're going to need to now address the foot plate, which is not flat, but that's, again, not a hard thing to do. We're going to mask that away. Turn on double so I can see what I'm doing. Maybe turn on isolation mode too. Ugh, looks like it's nasty. So we're going to feather that, hit W on our keyboard, bring our gizmo to the floor plane, and we're going to flatten this, maybe without the sidewalls. Once go, turn that. Let's flatten this down. There we go. If we turn on our original, we can see where, what we have to match to in terms of what this should be. So we're going to bring the liner now into line with the AFO that we just made. And there we have it. So now that that's done, we have all of the pieces we need to transition out of a mesh workspace and into a CAD-based workspace. The last thing we want to do is maybe bring in our scan to the mesh workspace as well, to our CAD workspace, sorry. And so this at 185,000 points is very unfriendly for CAD. Any CAD package you try to bring that into, it will cry. So we are going to quickly do a reduce function. We're going to process this scan and reduce it to, I would say, about 18,000 points. So 10% of its original size. So if I decimate this, bam, nice and friendly mesh for CAD. So there's our aligned mesh. There is our quad mesh for our AFO liner, and there is the AFO liner quad as well. So these are the pieces, guys. This is all you need from a 3D scan in order to hop into CAD. So let's quickly now check our scale to make sure this is correct, and then we are going to export this as an OBJ. It has to be an OBJ. So we're going to export this out, and we're going to save. And that's it, guys. So let me now, I have to transition to another window, I believe. Just bear with me here. So StreamYard, do I have to present a new stop screen share? We're going to present the next screen, which is going to be a window of Fusion 360. All right. So we're going to hide this. And let's completely change gears, because now we're inside of a CAD workspace, right? So this is where product design really does shine. Product design and being able to measure, being able to create parametric templates and files that can move around and, you know, create a 3D printable file, right? The first step is processing your 3D scan into usable CAD assets. The next part is now we're going to create an actual CAD design. So one of the cool things you're going to learn in the course is how to create time-saving templates and files for yourself. So if I go into hardware, one of the first things I can bring in is an actually predefined map, you know, a part that's just sketches. And this is a sketch that drives my ankle placement for the AFOs. It's a nice small little piece. It's really easy to use. Interesting. My viewer is showing a black bar for the browser. That's hopefully not going to be in the way. So that is a smart sketch. It's just two little sketches on a plane that helps me map my ankles. And, you know, I could spend 10 minutes in front of you drawing this, or I could save this in its own file and bring it in and, you know, write it once and use it a ton. So this is exactly what I'm going to do. I'm going to bring in this map. And finally, now that we've done that, let's create that new component for these meshes we brought in, we made. And let's do this exact same thing. So we're going to bring in the scan, the AFO, and the liner quad to this workspace. So we're going to align this to our viewing cube. So front is front. We're going to center this. We're going to move it to ground, and we're going to try and keep the origin point at the center of heel, or the touchdown point of the heel. So spending just 10 seconds bringing this to floor and aligning this is going to save us a lot of headache. So something like this. I think that looks pretty good. So now that we've done that, we have a container for our meshes. And there we go. So let's also bring in our final piece of hardware. So I also have a predefined template that, again, you will also learn how to build in some of our courses, is a tamarack joint. And so this tamarack joint has a bunch of cool little tools and features in it that allow us to do things like, you know, cutting tools. So there is in this tamarack joint part, you know, there's a cutting tool that we can use to cut away from things. We have a merge tool, which is the actual wall, you know, that we want this to fit. We have the screws called out from a McMaster card library, and then we actually have the body of the tamarack itself. So by spending the time again to make these parts for yourself, you can set up a template that does a lot of work for you and prevents you from doing the same work over and over and over again. So I'm going to bring in these tamarack joints. Oh, and you know what? I brought it inside the meshes container. Oh, that's not fun. You know what? I'm going to have to do that one more time. Bring it into the top level assembly, because my meshes container is for my meshes, not for my components. All right, sorry guys, here we go. So there is the second part of this you know, template that we're going to use. We have all the pieces we need now to be able to build this design. So first off, let's create a joint and an assembly so that we can actually match up our mapping to the tamarack joint. So I'm going to bring in, I'm going to throw up a joint. So we're going to bring that together and hit OK. And then we're going to copy that tamarack joint, create a second, move it over here. And we're going to do the same thing here. We're going to create a joint from that sketch that we made to the actual tamarack joint itself. So what this allows us to do is we can now update our mapping, and our joints are going to move around too. So if I need to create higher clearance between the ankle bone and the tamarack joints, I can very quickly map that out. And if we need to change the position of where these line up, I can also do that too very quickly. So for example, let's create a cross section here, and let's just map this out a bit more accurately. So again, you guys will have your own logic. This can vary from practitioner to practitioner. So what I'm doing here is sort of a 5-degree tilt off of the medial heel bone at this highest point, and then I'm giving a 4mm offset from that. So this one's a little high. Let's change this down to 36, maybe 33 or 33. Let's try 33. Not close enough. Again, we can move this around a lot. And if I turn off my section analysis, we can see it's about the right height, maybe a little less. So maybe let's bring that down to 87. So we'll call that good for now. So we have our map, we have our parts. Let us try and create the actual device now. So new component, let's start off with that liner that we made. We're going to create a container for the liner. Let's go and in our solid workspace, let's create a form, and let's convert that quad mesh we made into a surface. So this is now a spline surface, and just like that, guys, we can take a mesh into CAD and turn it into a CAD surface with one click. And that's the beauty of quad meshing. So with that, let's do our next main command, which is we're going to thicken this out by, let's say 2.5 millimeters. Just to, and this again can be whatever you want it to be. I got to make sure that I turn on soft edging, which is also a really useful feature in Fusion, that we can have soft edges for this part. So just like that, we have a completed solid, a 3D printable solid with nice geometry. If I hit OK, it's been auto surfaced, it's in place, we are good to go. So right here, if I hit A on my keyboard, let's quickly give this a material so we can see it. And that part technically would be done. So let's now create a new component, and let's do the actual device, AFO. So same thing, we're going to go in and we're going to convert a quad mesh. So we're going to take that quad mesh that we made and we're going to hit OK. And there it is, just like that. We have a surface that we can work from. So now we got to do something similar here. We got to thicken this, but this time we got to thicken it without connecting them. So we're going to create that clearance from the liner. So the liner was 2.5. We're going to create a surface at 2.7. Then we're going to repeat that thicken on that 2.7 to, let's say, 3.5 millimeters. 3.5 millimeters or 4 millimeters. It's a good size for an AFO in terms of its thickness. Actually, I might just go 4 because 4 seems to be a bit stronger. We do something like that, and we have that completed solid, just like that. We didn't have to do any other work, and it's nice geometry, guys. It's really nice. It's CAD friendly. We don't have to worry about hollowing. We don't have to worry about things breaking, not being able to round our edges. So if I hit OK now and hit finish, there it is. We have an auto-surfaced AFO cover, or an AFO design. I'm going to quickly add a material to this as well. Let's just put that black MJF part texture on there because that makes it look nice. So more or less pretty easy, but we still have the biggest job left to do. Is we got to connect these tamarack joints to the part we made, and we got to separate this now into a yoke and a foot plate. So let's quickly do that now. So continuing on in this, we're going to split. We're going to split the body. We're going to use that predefined plane that's been set up in our template, so we don't have to worry. There it is in our bodies now. Let's hide one and focus on the other. So we got to create a distance between those seams. So I'm going to sort of just bump this back minus 2.5 millimeters using the push-pull command. Oops. And same thing again for the other side. We're going to push-pull this design, this part back, minus 2.5 millimeters. Okay. So we have that. And now we're going to sort of combine these together. Now I want to work on each piece separately, which means I actually have to cut this in half. So both of these parts I want to cut into sort of down the middle. So I can select that YZ plane from the origin, slice this in half, and we can now sort of hide what we don't want to see. Okay, we can hide our meshes, hide the meshes. What is this? Okay, there's a body in there that we don't like. There's this, which is also a mesh. All right. And then the tamarack, that one. Okay, so we're just focusing in on these ones. So how do we take this surface we made and how do we combine it to our template here? Well, I've got some cool tools here that are going to help us with this. We're going to start off by splitting the yoke with one of these circles. And then we're going to do the same thing again with the bottom. And we're going to now hide these and get rid of them. And we now are going to flip from a solid workflow to a surfacing workflow, because what this allows me to do is I can now select a bunch of surfaces and just straight up delete them. So you're going to see why this is useful. So I can select all of those surfaces and then all of these surfaces and just hit delete. Now we've got open geometry, 2D geometry with it inside. So we're going to have to fix that. Now that this is, can I remove these sketches? They're in the way. There we go. So cool tip about getting this done quickly. Just focus on doing the edges. If you can loft an edge, 90% of your work is done. So I'll show you what I mean. So we're going to do that. And this is the tedious part, unfortunately. This is the only tedious part of this process, is combining these tamarack joints together to the body. But it's an elegant end result. And not only that, we can change our mapping for the ankle again, even after this is done, and everything is going to move around, which is really exciting. So now that that's been stitched together, we can patch the difference without having to worry about all of those edges, because it's always a pain. So now that we've stitched all that together, we have side one. And what's great about side one is that if we need to, after the fact, if something doesn't fit, we can still go in and we can still move things around, which is really cool, because these are sort of lofted edges or surfaces. So if you have that ability to change the template, change the patient information after this has been set up. So again, you do the work once, and you have a file that can be bumped around and moved around to help you with modifications or edits, approvals. If you have multiple people on your team trying to do the same thing and they want their input, they can have their input. So we're going to just go through this real quick, just like this. And we're going to merge these together. Right, and then we are going to patch this all together. There we go, patch, repeat, and we're going to patch just like that. And we're going to create a final body with something like this. Perfect. So you can see that geometry, right? It's really nice. If we bring back our meshes, the actual meshes, you can see how this now, if I need to move this around, I can. And if I even want to, where is that tamarack sketch? If I need to change how it blends, I can do that too. I can change where and how sharp this blend takes place just by bumping around a few sketches, which really makes the process sort of robust. It allows you to have good control over your setup. So that template is one of the cool things you learn in the course, is how to use CAD workflows to save you time and to set up templates for yourself. So now that we've done that side, we gotta go do the other side, and that's sort of the tedious bit again. So what I can do is sort of continue on the demo using another file, because I did do this already. So we can continue on. So imagine we did the same thing over here, same thing, and we're now sort of going to continue on with this. So what else can we do now that we have this shape in place? Well, we can put in some slots for your straps. So let's create a sketch on the side plane. And let's look at it from the side. Let's create an arc slot from here to here and sort of match that with a 4 millimeter slot. We can look at it from the side view on the other side and do the exact same thing. Another center point slot, but this time we're going to sort of go the opposite tangent Z. So at 4 millimeters. Perfect. We also have a hole we can put up here for where we want to put our clasps potentially. So this can be a pilot hole or something like this. So now that we have those mapped out, let's turn on our sketches. Let's first off just punch this symmetrically, distance through all, and just punch that hole right through. Nice and easy. And again, if we need to move that, now that it's done, we can do that. Same with these. Hit E on my keyboard to extrude. Holding down Shift. Nope, this one. There we go. Extrude that one straight through, making sure we are only cutting, not the liner, just the component. Same thing over here. We're going to do the concave one this time, and we're going to punch that through here. Right, being sure not to cut the liner. Fantastic. So we got our holes. We've got our strap clasps. Let's do a heel stabilizer, because that's also something that's commonly done. So looking at it from the bottom, we can quickly use our line tool to draw a heel stabilizer across the bottom. Put that in place, making sure we have a tangency here. That would be nice to have. And we could make this go up and down just to make things easy. Change that. We can dimension this if we need to, but mostly just making sure we match to the body of the AFO is nice. Let's E on our keyboard here. We're inside the part right now, which is not great. So we're going to offset this by -5. No, let's try -12. Right, and then distance to object, we're going to select the entire object, and boom, there it is. If we need to bring this back, we can go -10. So this is from the foot plane, right? So where you can tell that this is a -10, 10 millimeter heel rise or stabilizer, and we can quickly bring that and add that in. If we hit F on our keyboard for filleting, we can try filleting this or giving it a rounded edge. So can we do 10 millimeters? Can we do 15 millimeters? Nope. How about 13? How about 12? Oh, 10 it is. Just like that. And then so another fillet on this side. Can we do 12? Maybe 8. There we go. Pretty good. So there's that piece. Finally, we can do sort of a stopper on the back, which is also another common feature. So what if I created a center point slot from here to here, going straight up and down, something like that. And we're just going to throw that down. We can dimension this or make that as relevant as we can. So I'm just actually going to split our surface, split a face. We're going to split this face and this face and this face with our with our sketch that we just made. And now when we have that, we can actually hit Q on our keyboard and hopefully just bring this out by, as a new offset, 10 millimeters. Hey, that looks like it'll work. And again, if we don't like where that is, because that does kind of cascade off the back, we can move this around and it should update just fine. Not sure. Yeah, I mean, it's okay. Maybe 10 millimeters was too much. Can we go, let's go 6 millimeters, 1/4 inch. That's a little better. F on our keyboard, let's round these edges. So can we make that 3? Nope. Can we make that 3, 4? Ooh, there it is. Can I hit OK? That might be a bit too much material. So, if we wanted to, we can make that smaller. I'll have to think about that one, though. Maybe I shouldn't push my luck. There we go. Oh, not bad. All right. So there it is, guys. We've successfully completed this design top to bottom using templates, using simple sketches, using auto surfacing in ZBrush for quad meshing. Finally, if we really wanted to, we could even bring in some extra pieces. So I'm going to bring in a strap lead. So This is also just a quick template that I made that can help visualize the design, even fill in a bill of materials. If you're deciding to do drawings of this, having this in place would actually be kind of nice to have. So I'm just going to bring this out for fun, just to show you what I'm talking about. So there is a quick little template that I made for a strap. We can now go and join that to the hole we just made. And if I did that right, let's try that again. Blue traveling. There we go. Let's try that. That's better. There we go. Hit OK. And this didn't. Oh, well, that's not nice. Why didn't you work? Okay, maybe this is the wrong template, but that should work. There we go. There you have it. So we could easily put those into place too, create variations, have things that are accurate. And just like that, guys, I think we have come to the end of the tutorial where we have a fully parametric CAD-based surface of our device. We can drag these out and just take a look at the results. So we have all these different parts that we can now potentially go and get 3D printed. So if you decide to take the course, not only do you learn all these different methods, but you learn how to leverage online manufacturing avenues to be able to go online and find quotes for yourself of these parts, so that you don't have to just end with the design. So if I go back to StreamYard, I'm going to stop screen sharing and then just present my entire screen, or maybe even just a window. Which one? Is it this one? Let's try this window. Perfect. So what I've done, guys, is I've gone online to 4 different online manufacturing centers that have 3D printing. So hubs.com is one of the big ones, and I uploaded these 2 parts, and you can see that I can get an instant quote: $106 to print this, $144 to print this. You can go into these and you can change things like the material that you're using, what scale it's at. Is it dyed black? Is it polished? Is there any bad thin walls? They actually review it for you. So that's really exciting. So I hope that, and then exometry at 255 or 134. So you can actually go and get these parts looked at right away, and you can start price comparing, what it would cost to produce these. So really interesting stuff, guys. And I'm excited to be able to continue on with this through the course. If you guys want to learn more, you can, again, use the, let me see if I can bring back the, add to stream. There we go. I'm going to bring myself back onto this. So I gotta actually enable that. That's the one thing I forgot to do, is enable this code. So I'm going to enable this, and then for the rest of the day, guys, if you want to be able to take advantage of this, you can get $100 off any of your courses. So, all right, I really appreciate it, you guys. This has been a lot of fun, and this is what I love to do for fun. I learn this kind of stuff. Coupon. Sorry, guys, this just didn't work, so I have to redo it again. Flat rate of 100. Apply to all products. Start coupon. Okay, there it is. Ugh. All right. So for the rest of the day and the day only, just for you guys, I really hope to see you guys inside the Academy. So let's do some design together.